With switches in a multiple switch infrastructure, we have to be concerned with how the two different switches interpret the two different broadcast domains when working with VLANs. Remember what my VLAN is, I have two different broadcast domains. With that traffic, there may be issues distinguishing between those two flows. The two flows are those going from switch 2 to switch 1 or from switch 1 to switch 2 if I have multiple VLANs put in place. So let's create a couple of different VLANs in here. We'll do the pink VLAN, and we'll do the blue VLAN, and we'll have a couple different ports in each switch that have pink and blue associated with them. So here we go, there's my pinks, there's my blues, maybe another pink down here. Now what we have is our pink VLAN, which we'll call engineering, and we have our blue VLAN, which we'll call sales. As we look at these devices, if I have a sales machine sitting down here, and it wants to talk to a sales machine that lives up here, what happens? We generate an ARP broadcast. But where does the broadcast go? It goes out all the blue ports. This trunk line is also a blue line. It's the same physical wire, but it carries blue broadcasts so that it can go out the blue ports, and the blue port to the PC I'm trying to talk to. We good with that? We should be. Let's think about pink. Here I've got a pink PC. The pink PC is trying to talk to a pink server over here. So what happens when the pink PC wants to talk to the pink server? It does a ARP broadcast for the MAC address to the pink server. Goes out the pink port, goes out the pink port, goes out the pink port, and yes, this one wire also has to be a pink wire, even though it's the same physical wire, so it can go out the pink ports, and the server can hear me. We're good with that as well. My question for you is now, how did switch 1 appear? How did switch 1 distinguish between the blue broadcast and the pink broadcast? Because the destination MAC address is my standard broadcast MAC address. If both VLANs use the same MAC address as a broadcast, which is standard, that's what we do, how does switch 1 distinguish between them? So what's in my MAC address header? Remember the PDU header that we had before? Our MAC address header? What's in here is a destination MAC, a source MAC, and a type field, which is our protocol identifier for the next header. There's nothing in here that tells me which VLAN I'm on. So effectively, we have a problem. So what the industry's decided to do, the IEEE, through the 802.1q working group, determined that they were going to create a VLAN tag. The VLAN tag needs to be inserted into the MAC address header. So what we actually do is we take the VLAN tag and we put it right in there between the source and the destination MAC address. So if I look at the overall tagging infrastructure, I would now have my destination, I would have my source, and then I have a type field that points to the VLAN tag, and then I have my original type field in here. So we inserted this data right here. So the ARP broadcast that comes out of pink is a standard ARP broadcast. When it goes to go up this wire, we insert a tag so that the switch does, not the PC. The PCs are no wiser about what's going on here than anything. They have no idea whether they're connected to a coaxial cable or into a switch infrastructure. And what happens is the pink broadcast goes up the wire. Before it does, it gets tagged here. It gets tagged here, sent up the wire with a tag. This switch sees, oh, that belongs to VLAN sales or VLAN pink, VLAN engineering, strips the tag off, and then just sends the ARP broadcast on to the device. So this tagging infrastructure is what we actually use. If we take a look at what that tagging infrastructure looks like, whoops, sorry about the click there. I take a look at the structure. This was my original PDU header, destination MAC, source MAC, my type link field. Again, if we were to go ahead and do this back out like we've done in other discussions, the grand PDU of something going someplace, whether it's an ARP broadcast or whatever it is, shows me with my application header, and then it shows me with my transport header, and it shows me with my IP header. Again, this is pretty generic, and it shows me my MAC address header. So what we're looking at here is just the frame PDU of my MAC address header. This section right here, this data, this is everything else. The section, destination, source, type length is this header. We split the header right here. We add another type so that we know there's an 802.1q frame. We add priority bits. We do a congestion frame indicator, and we have our VLAN ID or our VLAN tag. And that's the overall structure that allows switches to distinguish between VLANs across a trunk port.